Okay, in this video we're going to talk about adding and subtracting radicals. The examples will be with square roots, but it applies to cube roots and fourth roots, etc. All right, the distributive property is going to be the important thing that we'll be using. So remember that if you have AB plus AC, and see this is a product here, A times B, and this one's another product, A times C, and we have a sum here, that could be written as A times the quantity of B plus C. So if there's a common factor, you can write that separately. And we often call this factoring. So we used it when we added like terms together, where we had 7x squared plus 3x squared. We learned we could just say, add the coefficients, 7 plus 3, and get 10x squared. This is the distributive property. They both have the x squared, so you can write that outside of the parentheses, and that's using the distributive property. And then you add the 10 and the 7 and the 3 and get 10 times x squared. So the common factor does not change. All right, so if you combine two like terms, you'll get another like term. Okay, so we'll use the same principle with square roots. So if you have 7 square root of 2 plus 3 square root of 2, using the distributive property, we can write this is the same thing as the quantity 7 plus 3 times the square root of 2. So what we have to have here are two radicals that are the same. We call those like radicals. All right, they have to be the same kind of radical, so they're both square roots, and they both have the same radicand. They both have 2. All right, and so then when you add 7 plus 3, you'll get 10 times the square root of 2. So if you add 7 square root of 2 plus 3 square root of 2, you're going to get 10 square root of 2, and you can do that in your head. If you are subtracting, it would be the same principle involved. 10 square root of 5 minus 6 square root of 5. The long way would be 10 minus 6, the quantity, times the square root of 5. But you would have 4 times the square root of 5. That'd be the answer, all right? Or here's one with several. 5 square root of 2 plus 7 square root of 2 plus 2 square root of 2. All right, so in this case, we have a 5, a 7 as coefficients, and a 1. So if you were going to write this the long way, and put the square root of 2 out here, you'd be adding 5 plus 7 plus 1. So you're going to end up with 13 times the square root of 2. Again, you can do that in your head. All right, now here's one that's got some unlike radicals in it. We've got 9 square root of 2 minus 3 square root of 7. Okay, so these are not like radicals because one has a 2 and the other has a 7. Plus 3 square root of 7 minus 2 square root of 5. All right, so what we're going to do is combine the like radicals together right here. These are like radicals. All right, now you can do this in your head. This has a coefficient basically of -3, and this one's +3. So if you combine those together, -3 plus +3, that's going to be 0. And 0 times the square root of 7, you're multiplying, that's just 0. So you really don't have to do any work here. You can see that those add up to 0. Now, the other terms, 9 times the square root of 2 minus 2 square root of 5, those are not like terms. So that's really all we're going to have. 9 square root of 2 minus 2 square root of 5. That answer does not simplify. And so we're left with kind of an ugly looking number. This is really just one number. This is an irrational number. It is a real number though, all right? If you approximate it and you use a calculator, 9 times the square root of 2 minus 2 times the square root of 5, it's approximately 8.2557, blah, blah, blah. So this is a number, okay? So it's somewhere on the number line, a little closer to 8 than it is 2. All right, it's just irrational number. Okay, here's another one where not everything is going to be like radical. We have 18 square root of 3 minus 14 plus 6 minus 11 square root of 3. Okay, so the 18 square root of 3 and the 11 square root of 3, those are like radicals. So in your head, you could go ahead and subtract those, and that would give you 7 square root of 3. All right, and I'm using the commutative and the associative property to rearrange the order of these terms. Now, I also have a minus 14, which you could think of as adding a negative 14 plus 6. And when you combine those together, you get a negative 8, adding a negative 8. So that would be subtracting 8. And then this does not simplify. That is it. We don't have any more like radicals to combine. And this is also an irrational number. If we approximate it, it's about 4.124. Right? So again, it has a place on the real number line very close to 4. All right, now here's the last kind of problem. You look at it, and at first glance, it looks like, okay, well, we're done. There are no like radicals. This has a 54, that has a 24. However, these are not in simplest radical form. We can work with these. So if you do a factor tree for 54, you'll have 3 squared times an extra 3 times 2. And if you do a factor tree for 24 and get the prime factorization, you'll have 2 squared times an extra 2 times 3. So you can see that these square roots have squares under them. There's the square root of 3 squared. So that simplifies. So we really have 4 times 3 on the outside, and then that's times 3 times 2, or 6. So this is really 12 times the square root of 6. That's what 4 square root of 54 is in simplest radical form. And then over in this one, the 24 has the square of 2, so we can simplify that. So we have a 2 that was originally there times another 2. 2 times 3 left underneath, so we have a 6. So then we're going to have plus 4 square root of 6, and you can see, oh, these are actually like radicals after all. Right? And so then if we add 12 and 4 together, we'll get 16 times the square root of 6. All right, that is the simplest radical form for that sum.